Alright, inshallah, we can get started. Bismillah ar-Rahman ar-Rahim. Alhamdulillah. Indeed, all praise is due to Allah subhanahu wa ta'ala. We praise Him and seek His help and forgiveness. We seek refuge in Allah subhanahu wa ta'ala from our soul's evil and our wrongdoings. He whom Allah guides, no one can misguide. And he whom Allah misguides, no one can guide. I bear witness that there is no God except Allah subhanahu wa ta'ala alone without any partners. And I bear witness that Muhammad sallallahu alayhi wa sallam is his abd and final messenger. Sending durood upon our Nabi sallallahu alayhi wa sallam. Allahumma salli ala Muhammad wa ala ali Muhammad kama sallayta ala Ibrahim wa ala ali Ibrahim innaka hamidun majid. Allahumma barik ala Muhammad wa ala ali Muhammad kama barakta ala Ibrahim wa ala ali Ibrahim innaka hamidun majid. Assalamu alaikum wa rahmatullahi wa barakatuhu. May peace and blessing be upon all of you who join in today. Thank you so much for joining in today. I welcome you all on behalf of ALMPG team to ALMPG's webinar on deep learning. I will be your host for today's session. My name is Dawood Ahmed. I'm a part of ALMPG team. So let's get started. Let's just jump into it. So moving on, what is going to be our agenda for today? We're going to just go through the introduction. What is deep learning? Where is it used? What type of deep learning are there? How does it work under the hood? How you can do it yourself with TensorFlow. Demonstration of the tool, and then detail of full course or training by the Big Bang Data Science Solution team. And then finally, at the end of the session, we can take the Q&A, question answer session, and we can answer all your questions. So we do have session time for Q&A. So don't worry about it. So moving on, can you guys hear and see my screen, right? I see one brother typing in no voice. Please, I'm not sure how he has joined in. Are you able to see my screen and hear me? Nobody from the audience can. Somebody from the audience reply yes or no. Yes. Okay. Got it. All right. Thank you. Let's move on. A little bit introduction about today's session. This is an informative session, webinar demo about deep learning. So we want to give you a glimpse, and the team of Big Data Science want to give you guys a glimpse of what is deep learning. And how we can build a career into it, what kind of expertise are required in it, skills are required in it, and how the data science team can help you guys, achieve that, inshallah. We can do that. And let's move on quickly to the webinar format. Webinar format would be for 2 hours, and at the end of the session, we will have a Q&A session. And if required, if the presenter wants to give a break, we can take a 5-minute break after an hour. So that will be a kind of webinar format. If you guys have any questions in between, just type in the chat box. The presenter can see, the Big Data Science Solution team can see it, and we can also see. We will try to answer those questions in the chat box too itself. Then now let's welcome Brother Mo Medwani and his partner Nathan Burnham. So I'm gonna pass the ball to Brother Medwani. He's gonna give us brief introduction, and then we can start the session. Brother Mo, I'm gonna unmute you. Inshallah, you can begin. Brother Mo, are you joined through your phone or? Okay, hold on. Nice. Brother Mo, can you type in your phone number so that I can unmute you?
Can you hear me, brother?
Yes, we can hear you. I have already unmuted you.
Okay, go ahead. Thank you, brother, for this webinar. It's really great coming back again with a great presentation in data science and data analytics, especially in the field of deep learning, trying to enlighten the community of the importance of learning data science before we miss the bus. So tonight we have, today we have another presentation on deep learning and TensorFlow. And I will be introducing my team after brother or Nathan. He is a computer engineer with extensive deep learning experience, and he has his own company, a robotics startup company, and he's our partner. And he has 4 years of experience in machine learning and robotic, and 7 years of experience with Python. And he's been teaching the deep learning at the master level on the 2016 and 2017. So definitely, inshallah, you'll be using him to learn from his experience, especially in the field of deep learning, which is taking over in data science. Also, I have Edward Bujak. He has 25 years of experience in IT, 18 years of experience in education, computer science, mathematics, and engineering. He has 2 master degrees. Myself, Mohamed Wani, I have over 15 years of experience in IT and service delivery management and data analytics. I have 7 years of experience in data analytics and 4 years of experience in data science and related technologies. I have 3 master degrees, Alhamdulillah, MBA, Master in IT, and a 3rd Master in Data Science and Data Analytics. And right now, I'm working on my PhD on Data Science and Data Analytics, and I am the founder of Big Bang Data Science Solutions. Alhamdulillah, we are doing great. I mean, so many things for the community, training the community on data science. We have 2 great programs running, up and running, 13-week program on data science end-to-end, and Nathan program, which is deep learning with Tensorflow. It's 8-week program. I'm going to pass the floor to Nathan. Nathan, the floor is yours. Thank you, brother.
Let's not wait anymore. Let's pass the ball to Nathan, and hopefully he can share his screen and we can get started. We are excited. I'm personally excited because in my company they have started artificial intelligence. They hired a couple of data science guys and they are doing this deep learning kind of stuff, you know. So I am excited myself. What is deep learning? Okay, Nathan, I'm passing you the ball, and also I'm gonna unmute you so you can speak and share your screen. Okay, Nathan, can you speak?
Hi, can you guys see my screen and hear me?
Perfect. Yes, we can do that. We can hear you clearly, and we can see your screen too. All right, you are on, man. Go ahead. Thank you for joining us, by the way.
Yep. Thanks for having me. All right, so welcome to the presentation on deep learning with TensorFlow. I'm Nathan Burnham. I have a little robotics startup, and I'm going to teach a class on this, and I have taught it already 2 years in a row at Mercer University as a master's level class there. Yes, there's a lot of interesting, fun stuff in deep learning, and there's there's some really great jobs and a lot of demand out there too. So the first thing is people have heard a lot of terms around deep learning, but people don't always know exactly what they are. So I'm going to go over a couple of the terms, and hopefully that helps clear up some things for the rest of the talk. So if you think of a Venn diagram, data science covers a whole lot of topics. So data science can be looking at all sorts of like big data and understanding trends, or doing some machine learning, or looking at patterns and things. There's a whole lot of topics under data science. And then there's artificial intelligence. And artificial intelligence, the definition changes a lot, but it covers a whole lot of other things. Almost all basic programming stuff might even fall under artificial intelligence. So data science and artificial intelligence cover a whole lot of different things and overlap some. Inside artificial intelligence, there's a type of artificial intelligence called machine learning. And machine learning is where you give data to an algorithm and then it learns something. Inside machine learning, there's one type of machine learning that's really, really taking off right now called deep learning. And that's the topic of the course and topic of this talk and everything. And deep learning is specifically uses something called neural networks, which is based on neurons in the brain. So it's trying to emulate what's going on in the brain at a very, very basic level, and it's getting some really, really good results. So when I say deep learning or neural networks, I'm really talking about the same thing. Neural networks are the tool that deep learning uses. And when I say machine learning, I'm probably talking about deep learning because deep learning is like the largest slice of the machine learning pie right now. And as you'll see in a second, all sorts of things are running on deep learning and neural networks. All right, so where did this all start? Deep learning has been around, well, neural networks have been around since like the 50s. But deep learning has really had a revolution since about 2012. And what happened in 2012 is that there's an image recognition competition that a deep neural network just destroyed. So over the years, people have been competing in this competition where they're given a picture and they have to decide, okay, is there a dog or is there a car or is there a cat in this picture? And it's been a really hard problem. So generally the way people have been approaching this is they'll look like, let's slice the image up like this, and then let's say if I see a line here and if there's a line here and if there's a line here, maybe I'll say it's a dog. But when you try and put together if-then rules to try and pull out whether something is like a dog or a car or a boat, it's really difficult. And this competition did 1,000 classes, so you had to 1,000 different types of pictures. So you really had to do a whole lot of work in order to get this to learn certain things. And before 2012, people were trying to use some like machine learning algorithms where you give it some data and stuff, but a lot of it was like most of the work was sort of by hand rules. But in 2012, a deep neural network came and it won by a huge margin. So it was so good at doing it compared to all of the algorithms that people had put so much work into it. And the real kicker is that the deep learning algorithm was simpler than all of the other ones. They put together a really simple algorithm, and then they just fed images through it. They just gave it the data, and then it learned all of the rules itself. It learned thousands and thousands of little tiny rules, and it took very little work for the team that did it. And it was, just way, way better than what the humans had been, trying to put together themselves for doing this. So this really shocked a lot of people in the machine learning field, and since 2012, deep learning has just really rocketed out, and everybody's using it everywhere. So, yes. All right, so let's talk a little bit about the types of neural networks here and where they're used, and then later we'll go on and look at like what they're made of and what they look like underneath. So the first type of neural network is like the default type of neural network called a feed-forward network, and in my class, this is you learn all of this stuff in weeks 1 and 2. I've got an 8-week class, but yeah. So here's some examples of where feed-forward networks are used in real life. One of my favorite ones is Google data centers. So Google has a bunch of data centers, and they have some of the world's best engineers that build data centers, and they also have some of the world's greenest data centers. So they've already optimized the data center a whole lot. But there's certain things that they can do. They can open a valve here, or open a window here, or turn on a fan here, in order to cool the data center and make sure that everything runs, you know, at a nice temperature and nothing melts or breaks or anything like that. So they had already had a really great system to optimize this, built by, you know, some of the world's smartest engineers. And what they did, though, is Google offered a little challenge to one of their machine learning branches inside the company, a part called DeepMind. And they challenged the little team to build a neural network that could beat the engineers at running the data center. And this is the results. So on the left, there's is the normal usage, and then they turn on the machine learning, and it drops by 15% power consumption, and then when they turn it back on, it goes back up to the normal level. So a machine learning algorithm was able to optimize all of the little levers and knobs and things that you can change in a data center better than the humans, you know, some of the world's best engineers. And this is actually sort of a big deal because data centers take up a lot of power. I don't have the current numbers, but in 2014, data centers use 2% of all U.S. power. And if one of the world's most efficient data centers could save 15% power, you think that it might have even bigger effects on other ones. So that's a huge amount of like just energy savings right there. And it's sort of an example of just how impressive this technology is. So other places you've seen feed-forward neural networks is on Netflix and Amazon and Hulu. Whenever it says, I think that you'd like to buy this product, or I think that you'd like to watch this video, all of those are run by a neural network now. They used to be run by other things, but now all of the companies have switched over, at least all of the big companies have switched over to running neural networks to run these recommendation systems. So yeah, in these systems, these neural networks are making these companies a whole lot of money because it's better at predicting whether you're going to buy an extra shoe or watch this video or not. And when you buy an extra thing from Amazon, Amazon makes a whole lot of money off of that. So yeah, these networks are very valuable to lots of companies. So one of the other places that you probably use neural networks every day is in Google search. Back around 2012, Google decided to add in a metric for deciding on what things that it gives to you in search. So Google has a whole bunch of different metrics that decide what results come to you in your Google search. But yeah, one of them is a deep neural network. And over the years, over the course of just a couple of years since 2012, the deep neural network has risen in importance to be the #1 most important metric when giving you your search results. So the most important thing that decides what things that you're going to get on Google is a deep neural network, which just shows sort of how powerful it is. So one other thing that you can do for it is prediction system. So I recently had a paper that I was working on, it's not published yet, where I was looking at voter data from in the United States over the last few elections. And I ran a deep neural network on the data, and I was able to predict 91% accuracy which way a person would vote based on where they lived and what their income was and how many children they had and things like that. And so that's sort of a scary thought, but yeah. So these things are pretty powerful. So next, the next type of neural network is a convolutional neural network. So feed-forward neural networks take sort of data that isn't structured in any way and learns off of it. A convolutional neural network will take images with a particular type of structure, with a spatial structure, which means images or sounds. So the example from ImageNet is, or the ImageNet competition uses convolutional neural networks. So one of the examples of this is just a farmer in Japan decided to use Tensorflow, the tool that we're going to talk about, to build a deep learning neural network to automate part of his farming. So he has to classify these cucumbers into different classes in order to sell them. So there's 2L, which is like, I guess, long, M, which is a medium length, S, 2S, and then there's BL, BM, BS, and C, depending on like how curved it is and how long it is and how shiny it is and things like that. So in order to do this, it's sort of really hard for even a human to see how to sort these into different classes. And so if you were to imagine how to write how are you going to write in like if-then statements to, like, let's say, let me measure how many pixels across it is or something, that would be a very, very difficult task. But instead, this farmer, who's not a tech expert, he has a conveyor belt and he put a camera on it, and he got a data set of what type of pickle it is, or a cucumber, versus what image it is. And then he fed just that data set to a neural network, and the neural network got really, really good at predicting from the picture what type of cucumber it is. So now, after he's got a trained neural network, he can put that on the assembly line, and it will now take a picture of the cucumber and put it in the right box for him. So he doesn't have to hire someone or do it himself, so that in order to sort these cucumbers, which would be, a hard task. But yeah, so you don't have to be a huge tech expert or techie in order to do deep learning. And just the general idea of what these convolutional neural networks look like, this is a little bit of an abstraction, but you can get a picture of a cat or dog, and then it lights up these neurons in different parts of the image, and then it sends it to another layer, and sends that to another layer, and sends that all the way to the end, and at the end it will spit out whether it's a cat or dog or boat or truck or whatever. And so in weeks 2 and 3, we will be talking about how to build these, and we will be building them ourselves. So some of the other places that convolutional neural networks have done some really interesting stuff is in the field of art. You can do a lot of interesting things. People talk about how deep, or how the last thing that machine learning is going to replace is artists, and unfortunately, I don't think that's going to be true, because we've seen some really, really interesting deep learning projects that can do really interesting art. So this is something called style transfer, where you take a picture of your kid or your grandmother or something, and then you take a picture of a famous photo or something, and then you do a style transfer, and at the end you'll have a picture of your grandmother or kid or something as if it was painted by Picasso or Monet or Leonardo da Vinci in the style of the picture that you chose. So here's some other examples. So here's a picture of the Mona Lisa, and then Starry Night, and then you have a picture of the Mona Lisa as if it was painted by Van Gogh in the style of Starry Night, right? So, and these are generated by a deep learning algorithm, which is, it's really interesting that is this powerful. And you can do other things with it. Here is the same image of some houses with different styles of artists here, so the Scream and Starry Night and stuff like that. And you can see the results are really good. And you can even do half and half. You can say, I want it half to be half of this style and half of another style. And yeah, it's very impressive. So another area that convolutional neural networks are in every part of your life probably is speech-to-text and text-to-speech recognition. So this so whenever you ask your phone verbally to do something like navigate home or you know, what's the capital of something, right? You can whenever it's doing a speech-to-text, there used to be better algorithms for it, but now deep convolutional networks are used to do most all of the good speech-to-text algorithms. But on the other side is something called WaveNet. So this network is made by Google, and it takes a line of audio and predicts the next thing in the next audio sample. So this is currently this WaveNet system is currently the world's best system to generate human-like speech or accurate sounding music. So just the past month or so, Google announced that they were using this algorithm to make all of the voices on Android phones better. So now, if you've heard the new voices on Android, they sound much better because of this specific algorithm right here, which is a convolutional neural network. It's got some extra twists to it, but yeah, Google is using convolutional neural networks to both listen to the text that you say and to generate text to speak back to you. So there's another branch of neural networks called recurrent neural networks, and this is in week 5 of my course. We will build one and we'll learn all about them. And recurrent neural networks are good for things that have time. So if you're speaking a sentence or you're typing a sentence or you have some string of audio or something, all of those have time. So you can pass in one word of the sentence, the next word of the sentence, the next word as one time step each. So the results of recurrent neural networks are probably the most powerful of the 3 that I've mentioned so far. They can learn all sorts of really interesting things. So this is the output of a neural network that was meant to produce Shakespeare. So the recurrent neural network was just given a whole bunch of Shakespeare, and then it was told to predict the next letter. So just given this sentence, you know, given all of the works of Shakespeare, given some sentence, you know, predict the next letter in the sentence, and then do it again and again and again. And eventually, after training it for a long time, it is able to produce new Shakespeare from scratch. So this little sample here is it can produce as much Shakespeare as you want, but this is a little sample of what it can produce. So they put in the capital letter P and said, okay, produce me some Shakespeare. And then it spit out an A, an N, and D, and continued for the whole thing. It even put in the capitals and the colons and the tabs and everything. So here it looks fairly convincing that it was written by a human and looks a lot like Shakespeare. And it's very impressive. Here's another example. Instead of giving it Shakespeare, they gave it the Linux source code. So this is the programming language C, and this is not part of the Linux source code at all. This is just made. This is made by the. This is made by a recurrent neural network from scratch, one character at a time, and so it has learned how to tab in things. It knows how if statements work. It knows how gotos work and stuff like that, but it hasn't learned all of the concepts. some of these things that it's calling have not been defined and stuff like that. It doesn't understand everything about how to code, but it knows what code looks like and can make things look nice. So, but still, that's really, really impressive. And this is an algorithm that all you do is you give it a whole bunch of data and say predict the next letter, and now at the end you can use it to produce new types of produce text by itself. So another thing that is commonly used for recurrent neural networks is sentiment analysis. So this is where you take a bit of text and you decide whether it's a positive or a negative sentence. So in the class, what we'll do is we'll take IMDb reviews of movies and have it predict whether they gave it a thumbs up or a thumbs down. So you'll build a neural network to read the sentence, and then it'll use its knowledge of the world and the sentence to decide whether it's a positive or negative review. And so an example that is fairly funny, I've seen use of this, is in the stock markets. So we don't know exactly what the algorithms that people are using in most of the stock prediction stuff, but the little bits that we do get to see are turning more and more to neural networks to predict stocks. And one funny example of that is with the company called Berkshire Hathaway and the actress called Anne Hathaway. When an article comes out that is positive about Anne Hathaway, you can see the stock for Berkshire Hathaway go up. So somebody is buying stock for Berkshire Hathaway whenever they see something about Anne Hathaway come out. So what that means is that somebody is reading news articles and deciding whether it's good or bad, and then buying the stock for that company. But in this case, they happen to mix up the actress Anne Hathaway and the company Berkshire Hathaway. But it's sort of a funny example. So the other place that recurrent neural networks are used, and you might use this, is Google Translate. Google just started using like a 3-layer recurrent neural network translation system, or a 3-layer encoder, 3-layer decoder, in their Google Translate. And we will, in the class, talk about how they did this exactly. And but just in just I think at the beginning of last year, they started using the neural network for it, and about that time it got better than, well, yeah, but before they started using deep neural networks, people would criticize the translation system and say, oh, it wasn't all that good. But nowadays, Google Translate is about as good as your average translator. So it's gotten very, very, very good. There's still people that can translate stuff better, but not a huge amount. So yes, and that's all just using recurrent neural networks. So those are like the 3 main types of neural networks. We will talk about other things, but there's a number of ways of using neural networks. So one way of using neural networks is doing unsupervised learning. And there are some really interesting results inside unsupervised learning, but the biggest thing that's going on right now is something called generative adversarial networks. So what you can do with the generative adversarial network is you set 2 neural networks to battle against each other, one to make fake images and one to decide whether an image is fake or not. And so all you need to do is get a whole bunch of something, so a whole bunch of examples of something, and then it will generate you new examples. In the class, we're going to do something where you take a bunch of images, say a Pokemon or cars or something like that, and it will produce you new images of Pokemon or cars that have never existed before. This example here is a celebrity one where the neural network will produce fake celebrities from a bunch of pictures of celebrities. So none of these people exist, and the pictures look pretty good except for some of them. But it's really impressive that just you give the neural network a random number and it will give you a random celebrity face that has never existed before. But that's just the beginning of using GANs. You can do that. You can do more impressive things with it. So this is a tool called Pix2Pix, and it's using a GAN with some extra stuff on it to generate an image from some specification. So here on the left is a picture where you can draw doors or balconies or windows or trims and stuff like that, and to describe a picture of a building you want. And then you hit process, and the neural network will take all of that specifications and draw you an image with the doors and balconies and windows and everything in the right spot. And the results are pretty good a lot of times, which is kind of crazy that neural networks are that good at building these types of things. Here's another example that's even more impressive, where you draw a picture of a cat with like a pencil on the left, and you hit process, and it will make you a completely filled in photo of a cat from the picture you drew, which is really, really cool. So the next type of use of it is reinforcement learning. So unsupervised learning is where you don't have labeled data, and reinforcement learning is where you also don't have labeled data, but instead you're playing a sort of game. So if I have a neural network that's doing something like running down a maze or something like that, trying to find something in a maze, right? You go left, you go straight, you go right, you go left, you go straight, right. And then at the end, you get a reward. Which of those moves was a good one, right? If you're playing Pac-Man or something like that, and you move up, down, left, right, up, down, and then you get a point, how do you say which one of those things was right and which one of those things was wrong? So in order to get a good set of data, in order to train your neural network, it's a difficult task. So deep reinforcement learning is a way of addressing this problem. And so this is the example of, this is actually the program that we will build as a project in the class. This is a DeepQ network, and this is a little Google branch that did it, actually the same one that did the data center. And they built a neural network that could play video games, and after a period of time, it actually gets pretty good. But if you leave that same neural network for a little bit longer, it will get even better. So if you just leave the neural network running for a longer period of time, it becomes superhuman and just is able to dominate the game. So the people who made this game didn't realize that the best way to play this specific breakout game, the people who wrote the algorithm for this neural network didn't know that the best strategy was to shoot the ball into the left-hand corner and then have it bounce around the top. And the neural network figured out a strategy like that by itself, which a lot of people call creative or something like that. But yes, so these algorithms are powerful in that this same algorithm you can run and train on any Atari game, and most of them it will become superhuman on. And speaking of that, the same part of Google, DeepMind, took that and about 2 years ago now beat the world's best Go player in Go with a similar algorithm. So this is using reinforcement learning, and yeah. So all of the AI experts were saying about a couple of years ago, before they did beat Lisa Dole, in Go, they thought that computer algorithms wouldn't be able to beat Go for another 10 years. They thought that Go was just that difficult compared to chess and other things. There's a lot of reasons why Go is more difficult. As far as how many possible moves there are in chess, there's about as many possible moves as there are molecules in our solar system. But in Go, there's more there's more possible moves than there are atoms in the universe, and more atoms for each atom. So if every atom had a whole universe, and you counted all the atoms in all of those universes, there'd still be more moves in Go that you could play. So searching it is really, really difficult. But they used a deep learning network, a deep reinforcement learning network, in order to become the world's best Go player. And after this, people thought, oh well, you can't use this algorithm in other games. So Google, in the last few months, also brought the same algorithm to chess, and it sort of blew away a lot of people in chess as well, because they thought that the algorithms that we had been building were about as good as algorithms could get in chess, which was a rating of about 3,600. But they brought in AlphaGo, and it just dominated the world's best chess programs. So now they think the best rating is around 4,100, which is pretty close to where the AlphaZero program is right now. So, and this is the same neural network that was running the Atari games, same neural network that could play AlphaGo, and it's all just deep learning. And so we'll talk about these systems in the class, and we'll also build this algorithm here that can play Atari games. The one game we'll focus on is a little lunar lander. So I do robotics, and up until 2012, it was a very, very difficult task to figure out how to get robots to move in the way you wanted it to. A human could take a robot and control it to pick up a cup or open, fold some laundry or something like that. But we didn't know how to do if-then rules in order to build something that could interact with the world, to play soccer or to, fold laundry or do anything like that. So now we can use reinforcement learning to program robots, and it's working really, really, really well. So you can see here there's a little ant, and he's playing soccer, and if you were trying to program in these moves into the ant by hand, you can imagine that would be very, very difficult. But with deep learning, you can let the neural network learn all of those thousands of rules itself. So yes, here's another example of a robot using deep learning. This is trying to open up a door, and there's some other bits of this video that I didn't throw in here where somebody actually moves the arm to the side and pulls the door shut and is fighting it, and even though it was never trained to handle a situation where somebody is coming in and pushing it around and stuff, the robot can still manage to open the door. So these neural networks are pretty robust as well. Another place that you'll see some reinforcement learning is in self-driving cars. So a lot of self-driving cars are using supervised learning, which is just normal deep neural networks, but a lot of them are now doing reinforcement learning as well. There's specifically an NVIDIA one where they had a self-driving car and they didn't tell it anything except that it had to stay on the road, and they let it run around in a parking lot until it learned how to drive, and it actually worked very well. So yeah, so there's some big areas of reinforcement learning coming around in robotics and self-driving cars too. All right, so I'm going to talk a little bit about how it works. Maybe this is a good point to take a stretch and go use the restroom or something like that, and we will continue on in 5 minutes, I think. Okay. All right, perfect.
Perfect. Yes, we can. Let's come back after 5 minutes. Yep. Thank you, Nathan.
Thanks.
Thank you.
Great.
All right, we are almost there. 1 more minute left. So let me, guys, for those people who are new to ALMPG, I want to give a kind of brief introduction about ALMPG. See, the whole concept of ALMPG started is to give back to the community and unite the community together. So our concept is that, if I have, it all started with sharing a job. If I work in a company, I have an internal job position in my place, and I see an opening there. Rather than going outside and looking for somebody, what I do is I just put that job opening on ALMPG.com, right? And somebody from my community and my friend circle can get, can get an opportunity to at least, apply for that job. So that is the kind of sharing and caring kind of model we have at ALMPG. Not only that, we are also working not just for the professionals, but also for entrepreneurs like Brother Mohamed Wani, Nathan. We want to encourage people from our community, kind of small businesses, to come up to, display their services, display their talent. We have a lot of gems in our community. We just need to discover them. So that's how it works, in ALMPG. So hopefully, if you have guys that haven't registered for ALMPG, go ahead, register yourself, and you can get a lot more about learning new technologies, not just in IT, but we have other fields too. So go on www.almpg.com and discover the website and learn for yourself and help others to grow. Thank you so much. Let's get back, Nathan. Where are you? Help. Okay, Nathan, are you up?
Yep. Thanks.
Yeah, go ahead.
All right, hopefully everybody is back. So let's talk a little bit about how these systems work underneath the hood. So, yeah. All right, so deep learning uses neural networks, and these neural networks are inspired by neurons in the brain. So this is a picture of a neuron. It's got dendrites on the left, which take in information, and then it sums up all that information in the main cell body, and then it spits out information along something called an axon to the right and sends it out to other neurons. So neurons are really, really complicated in the brain, and they are, really interesting cells. But in order to run neural networks, we stole just the really basic idea of a neuron. So the very basics looks like this. So we have some inputs, some x1, x2, x3, xn on the left coming in. And then we have some weights, which are just a number, which we multiply by the input, and we sum them together. And then we run it through an activation function, which is a threshold, and yeah. So all of this is actually really simple. So for example, let's say that this is a neuron that's that predicts whether it's looking at a cat or not. And we have a bunch of inputs on the in. So x1 could be ears, x2 could be eyes, x3 could be a beak, and xn could be a tail, right? So if we have something come in that has ears, eyes, and a tail, we want it to spit out that it's a cat. We want it to spit out the end that's a positive thing. But if we see a beak, we want it to spit out nothing. So what we'll do is we'll have the weights here, and the weight 1 for ears will be a big number. So ears are important to whether this is a cat or not. Eyes are important to whether this is a cat or not. And then beak will be a big negative number. If we see a beak, we're pretty confident that this isn't a cat. And then if we see a tail, that's also a big number. And then what we do is we just multiply it, how much tail we see, by how important tail is, and then we do that for all of the different inputs, and we add all those numbers together, and then we check that it's greater than 0. That's what the activation function is. If it's not greater than 0, we just make it 0 and we don't output anything. And so this is the neuron, and this is what's running everything, right? So this is what's running Google Search. This is what's running, these autonomous cars and everything. So this is one neuron. But in order to make this thing do something more complicated, we're going to put them together in networks. So what we do is all of the blue circles here are neurons. And we have some inputs come in, and we feed it to a bunch of neurons, and then those neurons send out their output to something. So we put these neurons into layers, and we can, So when we want to program these in the computer, we put these numbers, these inputs in something called a matrix, which is just a list of numbers. And then we can multiply these lists of numbers by the weights and stuff like that. And all of it is very simple as far as like the algorithm. And you just need to tell it which things you need to multiply by what things. So what that looks like in the computer is this. So we take X, our input, multiply it by our weights, W, add a B, which is something we'll talk about in the class, and then we check that it's greater than 0. And so that's the math that you have to do. You just you have to be able to multiply, add, and check if something's bigger than 0. And this is what powers everything, right? So this stuff can take your voice and turn it into text, and can generate images, and can do all sorts of things. And if you want to make a more complicated neural network, we can make another layer. So the first layer takes in X as an input, and then it outputs Y1. And then the next one takes Y1 as an input and outputs Y2. And all of it is just another, we just multiply the input times some weights, and we check if it's greater than 0. And we just do that twice now. And a deep neural network might have 30 layers or something. So, yeah. So here's a little example of a neural network running. And what we have on the left, the first 2 boxes on the left are some inputs that say for each point whether it is how far to left or right it is, and for each point for X2, how far up and down it is. And then we have some 6 neurons, 4 in the first layer, and then 2 in the last layer. And then at the end, we have just the output, and you can see what it looks like. So we have some neurons at the beginning, they have just random connections. And over time, we run some data through. We look at a single point, and we run it through. As this point might be on the left side and the bottom. And then we run through all the neurons, and at the end, we get an output that says, I think that this point is blue, or I think this point is orange. And at that point, you can go and say, were you right or wrong? If it's wrong, it will go and change the weights. So it will go and say, you were the one who said that it was, blue the most. So I'm going to say that you're blamed 80%, right? And then that neuron will say, well, I was told that it was blue the most by these guys over here. And, you neuron, you get 80% of that blame. So the blame says, okay, well, this neuron gets 80% and that neuron gets 20% of the blame, and then those neurons send their blame over to the previous network, or the previous layer, and then those layers send it on back. So so if you get an error, it will change the weights of the graph just a little bit by passing back the errors to the previous neurons. And all of the math behind that is also fairly straightforward. But fortunately, you don't have to do it because there's nice tools called Tensorflow, and well, one of them is Tensorflow, that will do all of that for you. So all you need to do in order to implement these systems is you just need to connect all of the neurons together, and then it will run the neural network for you and do all the learning for you. So yeah, we'll show more demos of this running in real life at the end. So a convolutional neural network is all of what I've talked about so far is a feed-forward neural network, and that just takes raw data. A convolutional neural network takes little feed-forward neural networks and runs it on every pixel in an image. So it'll slide across the image and do its neural network stuff on every pixel. Ding, 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 and move along, and it outputs a whole bunch of stuff. And then you slide those images across and for a whole bunch of layers. So this is, the general idea is some of those pixels will have a really high activation for those neurons, and some of them won't. So you can see here that some ideas Yeah, so some activations come and trickle up through the layers, and eventually dog is selected at the end. The neuron that says dog is the one that fires. So when you look inside at what these little neural networks that get slid across the image look like, you can see that they recognize some interesting things. So at the very bottom layer, the neurons are just putting together information, like raw information. So you can see that they generally do lines, horizontal and vertical and diagonal and different colors. And so they can recognize basic patterns with one layer of a convolutional neural network. And when you put another layer on, now it's putting together combinations of those first layers. So you can see that it can now do circles. And so yeah, in the top right, you can see that there's like some tiger stripes sort of in corners and other colors and circles and stuff, because it's putting together the combinations of colors and lines from the very first layer. And now the third layer can put together combinations of circles and corners and stuff. It can put together more complicated systems. And we can already see some really complicated results that it can pull out already. So the top left on the layer 3 is it already pulls out like tiger stripes. And sort of down by the bottom, there's something that recognizes pumpkins. And then in the middle, there's something that recognizes car tires. And the bottom right is one that recognizes humans already. So just 3 layers, it's recognized the shape of a human. If you add more layers, it can recognize humans in different poses. And then more layers, it can recognize, like, I see a human and a dog and a coffee cup, so this must be a coffee shop or something like that. So it can recognize more and more complicated things as you add more layers. So yeah, but the amazing thing is that all of these start random, and then you just give it a task, and all of these features are learned by itself. So other things you can do with a convolutional neural network is this left-hand side is sort of the normal convolutional neural network, where you take a picture and you shrink it down into data. But what you can also do is an inverted convolutional neural network, where you take data and you expand it back up to an image. So here we're producing an image that is where the dog is in the picture. But we could produce all sorts of things. So we could take a picture on the left that is a picture of daytime, and we could make it the same picture in nighttime on the right. One of my favorite examples of a deconvolutional neural network is a network that you can enhance pictures. So you can zoom into pictures that are low resolution. So what will happen is you take in a picture on the left that is a low resolution image, like in CSI, and then they'll say, zoom in to that person's face. And they'll zoom in a bit, and the neural network will spit out a higher resolution image. Now, what that means, though, in this situation is that the neural network understands that, oh, I see a face, and what I'm going to do is I am going to fill in the details of the face, but I'm just going to make them up. So if you zoom into this image, you can zoom in as much as you want, but it's going to make up all the details as it goes. And these are pretty interesting, pretty powerful systems that, yeah, they can do some really interesting things. So a recurrent neural network is, instead of sending things or sliding things or whatever, they're all just, all of these systems are using the same formula, just Wx plus B is greater than 0. But instead of sending things, you're just connecting the things differently in both convolutional neural networks and in recurrent neural networks. So this recurrent neural network will take an input normally. For example, this could be a sentence, the dog went down the road. And xt minus 1 would be the, and xt would be dog, and xt plus 1 would be went. And So it'll take in an input from there, but it will also take in an input from the previous time step. And then it'll send out an output, which could be a new word or something. It could be the word in French or something. And it will also spit out an output to its next time step. So instead of just having the arrows just going completely vertical, it's sending something back to itself. And that's the difference between a recurrent neural network and a regular one. So there is a more complicated way to connect them up with more valves and stuff called an LSTM. And this is the thing that runs Google's translation system. It's not that much more complicated. It's all exactly the same formulas, just WX plus B is greater than 0. You just connect a couple of them together in different ways. And, we talk about this in the class and everything. So what you can do is you can put together actually a fairly easy recurrent neural network translation system with a pretty small data set yourself. This is surprisingly easier than you think. And here it's taking in I am a sentence, and then at the end the recurrent neural network spits out the same sentence in French. So how do we do this in practice is with a tool called Tensorflow. So Tensorflow is a tool made by Google. Google had something in the past that they were using to run neural networks inside of Google and Google search and stuff. But they realized that it didn't do everything they wanted. So they made an open source platform that would be really performant and would do everything they want, called TensorFlow. And now every team at Google has to use this tool. So when something goes, when some team wants to do something that it can't do yet, somebody at Google will quickly add some code to do it, and you'll have, new features really, really fast. So what is TensorFlow? So an array is a list of numbers, and if you have an array, if you have a list of numbers that has both a length and a width, so you list them to the side and down, you have a multi-dimensional array, so two dimensions. And you can have more than just 2 dimensions, but when you put numbers in lists in multiple directions, that's called a tensor. And flow is a graph of operations, which is where you put some operation and connect it to another one. And in TensorFlow, what you do is you take these boxes of numbers and you stick it in the front of your machine, and it will send the numbers and do some computing on it and send it off to other nodes in this network. So so TensorFlow is by far the most popular deep learning framework right now. It's fully backed by Google. It's got a really great community. It's super easy. It's also really powerful, and it's made to be run at Google scale. So a little example of what you need to do to run it is this is about half the code that you need to run it, but this is the equation for a layer of neural network that I put together at the beginning. So X here is the input that's taking in a picture in this case, and W is the weights, the importance for all 10 of our neurons, and then B is something that we'll talk about later, and then at the bottom line we multiply our X times W, add B, and then we run it through something that turns it into percentages, and then we have our output. And this is the hardest way to build a neural network in TensorFlow. There's an easier way that looks like this, and it's just one line. So you can just make one layer of a neural network with 10 neurons in just one line, and if you want to put a couple more lines, you just copy that line a couple more times, or a couple more layers to make a more complex neural network. And running it is about a few more lines than that. but it's not all that complicated. And so what does TensorFlow look like underneath? In order to run things quickly, you don't want to use Python. Python is actually kind of slow, but Python is the language that we use to interface with TensorFlow. So in the Python side, we put together a blueprint that says this operation is connected to this, is connected to this, is connected to this. And we just connect all these nodes together. But when we say run, it goes down into a lower level and gets run in C on a CPU or a GPU or on an Android device or something like that. And yeah, so it gets run really performantly at the very bottom is the fastest way. But you can edit it and set up all the stuff in a really easy language called Python. And where can you run it? You can run it on a laptop, in a data center, on Android, iOS, Raspberry Pi. There were a couple projects I was doing, which was taking text out of documents and reading through documents and pulling out the relevant text. And I was throwing up lots and lots of machine learning or lots and lots of GPUs up on a data center and running my neural networks up on Google's data center. And you can actually you can get a lot of learning done real fast on a data center. But you can also train a neural network and stick it on an Android device or an iOS device. Yeah, so this is sort of on the right. There's a picture that sort of shows how these graphs are connected. And the bottom box there is the WX plus B that we talked about. It's got two layers here and then some extra stuff on top, but it sort of connects together in a graph like this. But yeah, so that's TensorFlow. I'll talk a little bit about the course. So yeah, I'm putting on an 8-week course that starts February 3rd, where you can learn everything that we've talked about. So we talked about feed-forward networks and how they work and how just optimization and neural networks work in week 1 and 2. And then we talked about images and convolutional neural networks in week 3 and 4. And then 5, we do recurrent neural networks with text and audio. And then week 6, we do unsupervised learning. And week 7, we do reinforcement learning. And week 8, we talk about other things where networks do complicated stuff with memory and attention, and also talk about how to build these systems ethically and stuff like that. At the end of the class, you end up with a portfolio with 5 projects on it. Right now, there are not a lot of colleges running these or doing deep learning. Because it only started in 2012, a lot of professors have not included this new stuff in their curriculum. And there's a huge demand for it because it's useful in lots and lots of places, but there are not that many people who know it and are teaching it. So there's a few colleges that do teach it, and the people who come out of those curriculums are being sucked up by Google and Amazon, and everybody complains online about you can't get any, you can't get any students from there because they're all going to, the biggest corporations. And also, the pay for deep learning is pretty good. At the end, at the end, you'll end up with a portfolio with 5 projects on it. So we do a feed-forward neural network where we classify data in some census data. And we'll look at census data and then be able to predict whether they make above $50,000 a year or less than $50,000 a year based on, some background that you have. And so that's just some data munging stuff. And then we do a convolutional neural network project where we'll take a bunch of images and we'll be able to classify them. So we'll be able to take any image and say, is there a desk, and or is there a chair or a cat or something in this? And yeah, so there's also lots of other computer images stuff. One thing that we'll add on to that convolutional neural network is location. So we'll be able to build a system that you put in a picture of a cat, and it will draw a box around the cat and say, I see that there's a cat right here, or a dog, or a plane, or something like that. And then the recurrent neural network, we're going to do the IMDb database, where we will take a sentence and we'll decide whether it's positive or negative. And after that, you'll be able to type in any sentence you want, and it'll tell you whether it is a positive or negative sentence. Of course, we're going to learn a lot more complicated things like Google's translation system, but we're doing, the project is a sentiment analysis thing. And then week 6 is an unsupervised learning project, and we're going to build a GAN. So this will be you'll be able to take a set of images, like a set of cars or Pokemon or something, and then you give it a random number, and it will produce you a new picture of a car that has never existed before. You know, it's not a Toyota or a Honda or anything. It's something that has never existed before. And then the reinforcement learning will build a DQN agent that can play any Atari game you want. I mean, really, it can play any game you give it. But the game that we are going to do is a lunar lander, where it learns to land a little spaceship on a little Mars platform. But it's really easy to put it on Pac-Man or anything you want, or on a robot. So the way the class is formatted is a synchronous remote. So we have 2 meeting times, Wednesday nights and Saturday mornings, or Saturday afternoon-ish. And so you can log in with GoToMeeting remotely, or you could view the lectures later if you can't make that particular time. And then so you're also welcome to take the class anytime after for free. We'll also try and help you with job placement and other things like that. And there'll be some extra sessions on resume building, and at the beginning some extra sessions on basic Python and stuff. There's only a little bit of Python that you need to do the course. But yeah. All right, so let's open up to, okay.
You can open the slide and show them. You can open the slide.
Oh, yes. All right, yes, let's, I'll open up the website. So this here is bigbang-datascience.com, and this is the deep learning course. And so you can find some more information here. We're starting February 3rd and ending March 28th. You can join us here in Atlanta or Alpharetta if you want, or you can join remotely. Either one works fine. So there's detailed information on what we're doing on each of the weeks. There's also some frequently asked questions. I think we'll probably answer them in a second. So the class price is $990, but if you're looking for a deep learning job, you will have a great portfolio compared to everybody else, and it'll be a small dime in the bucket compared to what you could make as a deep learning engineer. And if you're interested in joining the course, definitely register on the website here and join our Facebook group. All right, so any questions?
So let me open up the Q&A session, and people please join in the queue, and we can then take your questions one by one. I'm going to put the session. Please join in. And Nathan, I'm going to unmute you once again, and also I'm going to unmute Madhwani.
Hey, Brother Mansour, do you still want to do the demo? We have a short demo.
I should run through a little bit more demo too. Yeah. Well, anyway, it's fine. I'll just talk a little bit about this quick.
Okay, let's do this. Let's do this. Let's finish up the demo, and then we can at the end take the question and answers. What do you say?
Oh yeah, sorry, I shouldn't have jumped to the Q&A.
No problem, no problem. That's fine, that's fine. So let me cancel that back, and let's go to. And
Okay.
let me. Okay, go ahead. Go ahead.
All right. So this is a live neural network here. So we can remove and add neurons to a layer here, and we can make more layers. So what we can again run this neural network, and it will learn that this part of the image is blue and this part's orange. But we can also run it on different examples, the same neural network. And so here, this is a pretty easy one. And we can also try more complicated images. So this one right here is really complicated if it's going to learn how to get all these spirals together. And you can see that it's learned 4 different things, and it's trying to put them together the best it can. But it hasn't really done all of that great of a job. So what we can do is we can add more neurons or add more layers and add more types of inputs, and we can run it again, and it will probably get a little better. So here, it doesn't take all that long to learn a much more complicated system. All right, here we go. It's still not beautiful, but it is much better than it was. So if you've got a problem that's harder, usually you can make a bigger neural network, and it will eventually solve it. So another fun thing to look at is the GAN. So this is the unsupervised learning, week 6, where 2 neural networks are fighting each other. But with this, we also have an example where we can take an image as an input and say, so we can say that you have to make an image that edges look like this. So we can do a processing here, and it built a cat image here that isn't quite right. But I can also add, some legs and, oh boy, tail and something, and we'll see what it builds here. And you can see that probably because of my drawing skills, it's not perfect, but you can see some other examples here where it's taking a picture of a cat, just a line drawing, and turning into a not terrible looking cat. So the project in the class will just be take a bunch of cat pictures, and it'll just generate these pictures itself, but not without the input, but with no input. You just give it a random number, and it'll give you a random cat picture out. But if you wanted to, you'll know how to build these other networks where you could add an input, and it will give you something. And so this also could run with things other than images. So you could do text or something like that, right? So you could say, give me CNN news articles, and it could spit out completely fake news articles that have never been, that never existed before. But yeah, so oh yeah, that's not a very good purse right there. So yeah, I'll just do one more. So draw sort of bag, process that. Yeah, well, it does. Handle, put a pocket on it, and it learns to draw an image with pocket on it. And if I make it more of a briefcase, see if it makes it into a briefcase. Not quite, but you can still see that it's quite an impressive system. All right. Well, yeah. So why don't we do? I think that's enough demo for right now. But why don't we open up for questions, and we'll see. Yeah.
Sure. Let's do that. Okay. Okay, people, whoever have questions, please join in the queue and you can ask your questions. Okay, we have our first question from Brother Afsar. I'm going to unmute you. Go ahead, ask your question, please.
Yeah. Hey, Assalamu alaikum. Is it audible?
Yes, we can hear you.
Okay. Yeah, great. So thank you for this wonderful presentation. So Jazakallah khair for whoever has been putting that effort. So I just wanted to quickly ask, so what is the prerequisite for joining this course? Is there are we expected to have some background? And because I'm basically from the ET programming, so I mean, is 8 weeks enough for me to have an understanding to get a job, or how does it work?
So so you need to know something about programming. So the Python that we need to use in the course and in a real job is very simple. So you need to know for loops, variables, if statements, and that's about it. So if you have dabbled in JavaScript or dabbled in, if you've just done the smallest amount of any programming language, you probably are fine. As far as the Python, I'll teach the specifics of Python, like, this is how you do a for loop and this is how you do an if statement and stuff. But the amount of Python that you need to actually run these deep learning systems is really small. And in the real world, you want to build really simple systems so that, I see a lot of big companies talk about trying to build as simple of a machine learning systems as possible so that there aren't any bugs in the Python code, right? So it's fairly hard to debug a neural network. So you want to make sure that it's not the code that matters. So in the real world, people are writing very, very simple neural network code as well.
Okay.
All right. Nathan, how about the job? After this course, the people will be prepared to give job interviews? Can you answer that question?
So you will, after the course, you'll know how to train neural networks, and you'll be able to answer all of the questions about, how to run something in a job interview. I've seen a couple people asking I've seen a lot of job postings around, and a lot of them are just like, if you can send me an example convolutional neural network, we will put you on our short list, right? So most people don't have examples of work they've done in deep learning, and there's so few people doing it right now that there's a lot of demand. And pay ranges I've seen for deep learning is like 100K to 200K-ish. So yeah.
Okay, lovely. Let's take another question from Brother Ejaz. Okay, Brother Ejaz, I'm going to unmute you. Go ahead.
Assalamu alaikum. I was just curious about, obviously I think, you have to input some training data. Is that correct? Like, so for it to identify that it's a cat, you got to put the N solution in there. Is that right? Or is it, that's why I'm kind of confused about this unsupervised or the learning piece of it. Is it learning that it's a cat, or is it already in there, and then as you input data, it will correctly put it into the right bucket? Does that make sense?
Yeah, so the vast majority of deep learning that goes on right now is called supervised learning, and it's the opposite of unsupervised learning. So supervised learning is you have a whole bunch of images, and they have labels on them that says this is a picture of a cat, and this is a picture of a dog, and this is a picture of a plane, and stuff like that. And there's a lot of data sets available for training those kind of images. It's a lot for most projects you'd want to do supervised learning, and you'd want to make sure that you have a big data set. But there are ways to train some systems without labeled data with unsupervised learning stuff, but there's some tricks you're doing to make that happen.
Would you say that unsupervised learning is kind of being developed still? I mean, more than probably less advanced or mature than supervised?
Yeah, definitely. It's definitely less mature right now, but we're getting some, we're getting some really cool results out, and people are using it in a lot of places right now.
And then one more question: are your courses? Are you teaching these courses throughout the years, or just like once a year?
I'm not sure yet, but this is the first time I'm doing this course as part of Big Bang Data Science. But I've done this course twice at Mercy University. But that only happens once a year. So I might run another session this year at Big Bang Data Science. So, but
okay,
the session that we're sure about is going to start in February 3rd.
Okay, thank you.
Okay, lovely. Let's take another question from Brother Abdul. Go ahead.
100 grams.
I think we can hear you. Hello? No?
Hello? Brother Abdul? Yeah. Okay, I think so let's do this.
Do you have a question?
Type in your question in the chat box. We will take that question. Not to worry. Okay, let's take another caller for now. Question is Brother Zen. Go ahead, Brother Zen. Hello.
All right. Well, I see a question here. Saeed asked, how different is this course for deep learning in comparison with the data science which Mr. Midwani took in the past? Mo's class talks about all sorts of different things in deep learning. One of the topics inside Mo's class is deep learning. Mo's class is on data science, and he talks about all sorts of different data science topics. One topic inside data science is deep learning, and he spends a week talking about feed-forward networks and convolutional neural networks and recurrent neural networks. But yeah, you might do one project in that or something, and it's certainly not as in-depth. And my class is 8 weeks on deep learning alone, and you'll really know it and be able to do a deep learning job at the end of it. So, yeah. All right, any more questions in the chat or audio?
I'm still looking for Brother Zan's question. Are you there? If you want to type in the chat box, I have unmuted you. Go ahead if you want to speak. Okay, I think he's dropped off. No problem. And we have one more question from in the chat box. He says, would training and no experience suffice in getting an interview and landing a job?
Yes, I think so. I don't think it'll get you a job at Google, but I think that you definitely get a job somewhere because there's such a big demand for this. It's sort of also in a lot of coding jobs, if people can see that you've got some examples of where you've done it. So if you're doing like web design and stuff, a lot of these coding design jobs need they don't care what degree you have. If you can do the work, then they're happy to hire you. I think that I've seen a lot of deep learning stuff. Most deep learning stuff don't require a specific degree in deep learning because there are not really those degrees in deep learning. So yeah. Let's see. Sorry, go on.
We have one more question from Brother Mudassir. He's asking, do we need strong math background for this? No, a strong math background would let you read some of the deep learning papers and stuff,
As far as what you need to understand, everything in the course is just basic multiplication and if statements and addition. There is some talks about slopes and stuff like that. Yeah, so we talk about derivatives, but all we talk about is just the slope of different things. So you don't need to know calculus or anything. If you do, I'll throw a little bit in there for people who can connect with that. But in order to understand everything in the course, you don't need a strong math background.
Right. Okay. And one more question. The brother Afsar, he's asking, what is the course fee for data science? It is not mentioned on the website.
Mo, do you want to answer?
Yeah, for that one is a 13-week program. The fee for the Ummah is actually $1,500. The regular price for the program with General Assembly, it's $16,000. But we're doing this for the Ummah very cheap. We're trying to educate the Ummah, get the Ummah a job, landing a job in data science.
Right. Very well. Thank you so much. And we have a question from Brother Salim. He's asking, he got like 11 plus years of experience in SQL and PL SQL. Is it a good idea to switch on deep learning as beginner?
I think that you could probably leverage your background in SQL in deep learning, because there is a good bit of it is using big data stuff, and if you know how to connect to an SQL database and use that really well, you should be able to organize your data and stuff better in deep learning. So I think you could leverage your background with SQL in the deep learning field a little bit too, yeah.
Okay, very well. Any more questions? I don't see any brothers or sisters. If you guys have any question, please type in the chat box. Oh, hold on. There is one question pending. Okay, we have Bhanu Prakash. He has one question. Okay, Bhanu, go ahead, brother. Bhanu Prakash, I have unmuted you. Go ahead if you want to speak up. Please go ahead. Or you can type in the chat box, man. No problem. Okay, let's take one more question from Brother Afsar. Go ahead, Afsar.
Yeah, assalamu alaikum again. I just had one more question. So since we are talking about data science and also the deep learning, does both the courses complement each other, or if I take data science, does it also include the deep learning part? Because we heard that there will be a 1 week session in data science. So how does it differentiate between two courses, and which one can we take?
Yeah.
Okay. So if you take a data science course, you will get access to almost everything you know to be a data scientist, and also you get access to some of the deep learning. We have 1 week of deep learning, but if you want to specialize in deep learning, if you want to go deeper, then you should take a Nathan class later on.
Okay, that answers my question. Thank you very much. Jazakallahu khair.
Any more questions? I'm sorry, go ahead.
And you can get a job just taking a deep learning class. You don't need. It's helpful to have a data science background to understand how to turn some company's raw data into something that you can use really easily for data science, but for deep learning. But if you don't, you can still do a whole lot of stuff. So lots of image processing and lots of stuff. Like I had somebody asked me if I would, I saw a job listing for a company that uses cameras to take pictures of license plates coming in and out of neighborhoods, and they wanted deep learning to pull out the images and to recognize what type of car it was and stuff, right? And you don't need data science to do that, but there's lots of areas where data science was helpful. Okay, so somebody asked here. Okay.
Yeah, take questions.
So, okay, yeah, let's see. I am new to data science. What is the prereq for deep learning? Can I start with this course? Yes, you can start with the deep learning course if you want. It depends on what you want to do. You can do either course. They cover different material, but they overlap just a little. As far as the other question, let's see. Would there be any help in resume preparation after taking the training course?
Yes, we have 1 week for Nathan and myself. We are going to have 1 week to help you guys prepare your resumes, for interviews. We have more than 500 questions to help you, real interview questions to help you prepare for interview, and also we will help you with job placement.
Mm-hmm. And as far as my course goes, you have a GitHub portfolio that you can give to people at the end.
Right.
And so I'll help you clean that up and make it look real nice. So yeah. So let's see. So there's one more question. Which is the best course to start, deep learning or data science? I think that either of them are fine places to start. They cover a lot of different information. Data science gets you familiar with lots and lots of different things. Deep learning is really deep into one subject. So it depends what your interest is.
At the end of the game, if you want to compete with others, you should know data science and deep learning. But if you really want to make a big paycheck, go to deep learning. If you want, you're talking about 300,000, 150, 160. Deep learning will lend you that job.
So after this course, how do you present yourself in interviews, starting course completion of deep learning course, and have zero work experience? Does this course provide certification? Yes, we provide you with a certification, and there isn't a standard global. There isn't like an industry certification, but we will give you a certification for doing our course, and also you will have a nice portfolio at the end. Most people coming out of even the few colleges that have deep learning programs, they might have one thing on their, one project that they could show to a company. And usually it's not the difficult type of deep learning, so not reinforcement or GANs or stuff like that. So you will have, most people will be looking for something convolutional or recurrent or something like that. And if you can show them that you've done much more difficult things than what they're looking for, you should be able to really blow their pants off, hopefully.
Yeah, I want to add one more important thing is you have the opportunity to repeat any of our programs that you took in the past at no cost, and we are going to help you with some projects. So you're going to be working on real projects, plus we will help you with job preparation, interview resumes, and help you with job placement.
Yeah.
All right, Jazakallah khair. And when is the course starting and timing? Can you just move up so that they can?
Sorry. So yes, the course information is here, and so it starts February 3rd, ends March 28th, and actually this time is actually wrong right here. I fixed it in one place, but I haven't uploaded the change. This is actually a typo. It's 12 p.m. to 2:30. This is Eastern time, and Wednesday 7 p.m. to 9:30 Eastern time.
Yeah, and for the 13-week program, we do it 3 times a week, every Saturday from 3 p.m. to 6 p.m. Eastern Time. This is physically if you live local, or remote if you are in different states. Every Tuesday and Thursday, on Wednesday, Tuesdays and Thursdays from 8 p.m. to 11 p.m. Eastern Time, and every Monday, Wednesdays, and Fridays we are going to be available 24/7. Especially to help you guys if you have any doubt, problems, any issues. We are off on Sundays.
Okay. We have a couple of more questions. Okay. What is this? Is there a job support in the beginning for a certain duration?
Is there job support in the beginning for a certain duration? What does he mean by that?
So can you explain more, please?
Yeah, go ahead.
I think I know what you're talking about. So, for example, if you have a job working on a project and you have having problems because as a starter, yes, definitely we are going to support you. We are going to be behind your shoulder, trying to help you succeed in your first or second projects. So once you complete 1 or 2 projects, yeah, you are good to go on your own.
Okay, lovely. And one brother, he's just giving a notice to you guys that he noticed the typo. So if you guys can.
I see that. Thank you for that. I will fix that today. I put all this stuff. Yeah, I put all this stuff together from scratch. So, but thank you.
Thank you so much. Any more questions? Are the recorded session available even after course completion? Yes.
Yes.
Can see on the screen.
Yeah. So you'll have all the access to everything in the course.
Yes.
So
the ALMPG, they are doing the recording session, so they are the one who handles that.
They were asking about the recordings of the from the course. Yeah.
Yeah, we have a recorded session. It's going to be posted on the Vimeo website, and it's password protected. So once you register, you should have access to everything. Can you please show them how to register? Nathan is going to show you where to go to register one more time.
So yeah, here at the bottom, there's please join the Facebook group and also come to the registration page here. And actually, it looks a little different right here. I'm already registered, so you'll see. Oh yes. Yeah. So yeah, registration here. This is the registration page. Just throw in your information, and we will catch up to you. Yes. Okay. All right. So let's see. There's a couple more questions.
Okay.
How many hours do we need to spend apart from course training time? Will there be assignments during the course? Yes. My course, you'll need to probably spend probably 4 hours over the course of the week to finish the assignments. So I'll be available to help you with those things if you need. But there's some basic quizzes and stuff. But then there's also some actual code that you need to complete each week to do the assignments, and all of the pieces of code will be in the presentation. So you'll have to adjust settings and figure out how to stick everything together. But the basics of how these things are assembled will be there. But so let's see. There's a question about how much time, or what is the timing for the remote sessions? up here, these are the meeting times. Saturdays from noon to actually 2:30, and Wednesday is 7 p.m. to 9:30 p.m. And this is Eastern time. I'm not sure what time zone you're in, so you'll have to check that.
Okay, lovely. And then let's take this last question, I believe, from Nadine. And she's asking, is there a forum where course participants can share ideas and support each other?
Yes, I have a Slack page for the course. And so people who register for the course will be added to that. And there'll be discussion on there. Also, if you want to talk about the course and just share things on deep learning and stuff, we have the Facebook group, which is sort of before the course interest sort of group. So yeah, if you're even inclined to take the course just a little bit and you're on the fence, definitely join the Facebook group. It doesn't lock you into anything. So yes. All right, so thank you so much.
Yeah, I think what is the course fee in Indian rupees for data science? Please calculate accordingly. I'm not sure what the Indian rate, so multiply it by the dollars, so you'll get your figures. So yeah. All right, I think we are good. Any more questions? Any more questions? Yes, that is correct, Brother Salim. Yeah. Okay, Brother Mo, you want to add something, or your partners like Edward or Nathan, you guys want to add something to at the end?
Yes, thank you for the time, and we look forward to working with you guys in the training. You can join me or join Nathan, but whatever your decision would be, my advice to you, brothers and sisters, is to go invest and learn in deep learning and data science, simply because it's the future, period.
Right. Nathan, you want to add something, man?
No, I think, well, I don't know. I don't have anything to say next.
Okay,
definitely check out the course page and join our Facebook group, and there you can reach me at my email or my cell as well.
Nathan, you can type in your email address so that if anybody wants to reach you out, they can do. Oh, you got it already. Yep, I see that. Okay, lovely. Yeah, people can reach you out then. And I think this is the end. This was a good session. Thank you, Nathan. Thank you, Brother Mo, and also your other partner, Ed. So thank you so much for coming on. And, this was a fantastic presentation. I really liked it. And there is so much so that, we have to learn with technology. We have to grow with technology. But I had one personal question. If all this is getting automated, then what about the manual jobs? Like clicking pictures, they are analyzing everything by themselves. So what's going to happen to a lot of jobs?
There's some big questions in that, and that's beyond the scope of that's above my pay grade. But yeah, we definitely need to be thinking about that as a society.
Yeah. That was like kind of my what happened.
But the answer to that, we are going to be dead. The machine is going to take over.
Well, hopefully not.
Hopefully not. Yeah. All right, guys. Once again, those who haven't registered ALMPG, please do so. We will have more such sessions in future. Please support this community effort of Brother Mo and his team, because this is, bringing in the gems out from the community and helping them. Our goal and our aim is to bring the professionals and also the entrepreneurs in our community together so that we can help each other out. Because we need to develop the entrepreneurs in our community. This is the part of being a kind of, this is what our religion teaches us, to take care of the community members. So we need to take care of it. If you guys are, if you felt that, this is a good course, take it. If you are not willing to take, go ahead. Let tell other about this course. maybe somebody else can get benefit from this course. So yeah, you can send in all your questions. If any questions are left to Brother Nathan or Brother Mo, just visit their website, right? It's Brother Mo, once again, what is the link for your website? Can you type in the chat box?
Yeah, brother, it's bigbang-datascience.com.
Okay, just go onto the website, guys, and check it out. And if you have any question, I think on the website they have the that's the website.
Thank you, brother.
Yeah. So okay, inshallah, and also support ALMPG any way possible. We are not here to make any profit. We are, alhamdulillah, trying to provide the community the platform where they can share jobs, share their questions, get help, and help each other out. It's a sharing and caring kind of concept we have. So Jazakallah khair, everybody, for joining. Thank you, Nathan. Thank you, Mo, and thank you, Edward, for joining us. So I would like to end here with the closing dua, a closing prayer. Subhana rabbika rabbil izzati amma yasifun, wa salamun ala al-mursaleen, walhamdulillahi rabbil alameen. Subhanakallahumma wa bihamdik, ashhadu an la ilaha illa ant, astaghfiruka wa atubu ilayk. بسم الله الرحمن الرحيم والعصر إن الإنسان لفي خسر إلا الذين آمنوا وعملوا الصالحات وتواصوا بالحق وتواصوا بالصبر. جزاكم الله خير, everybody, for joining us. Stay tuned for next upcoming webinars, inshallah. Until then, this is your brother Dawood Ahmed from ALMPG team with brother Riyaz, who is in the background answering your chat box. So we will see you for in the next session. Thank you, guys. Thank you for joining in.
Thanks.